few videos. First one is about Chandrayaan-3 landing on the moon on August 23rd. Second one is about G20 summit held in India from September 9th until 10th. Please enjoy.
This point are providing confirmation of the safety of the landing site.
As expected, the retargeting is going on, and this is a very good signature for the lander. अभी आप ये देख सकते हैं कि लैंडर की ऊंचाई लगभग 65 मीटर के आसपास बची हुई है.
Currently, only 2 engines are now being fired, and we are nearly at zero velocity, vertical and horizontal. We were hovering and now we are approaching the moon surface.
धीरे-धीरे लैंडर की वेगबान को कम किया जा रहा है और हम अब लगभग 50 मीटर से भी कम आ चुके हैं.
We can see the Honorable Prime Minister, Shri Narendra Modi ji, who is here to encourage us. He is critically looking at the visuals.
जी हाँ, आप अपनी स्क्रीन पे देख सकते हैं कि हम लैंडर मॉड्यूल
People are applauding. Let us all wait to hear from the Secretary Department of Space and Chairman ISRO, Shri S. Somnath.
लैंडर मॉड्यूल पूरी तरह से
सेफली और सॉफ्टली चंद्रमा के सतह पे लैंड हो चुका है. ये हम लोगों के लिए बहुत ही गर्व की बात है. हिंदी में एक कहावत है.
Your Highnesses, Excellencies, G20 के प्रेसिडेंट के तौर पर भारत आप सभी का हार्दिक स्वागत करता है. भारत की G20 प्रेसिडेंसी देश के भीतर और देश के बाहर इंक्लूजन का, सबका साथ का प्रतीक बन गई है. आप सबकी सहमति से मैं अफ्रीकन यूनियन के अध्यक्ष को G20 के स्थायी सदस्य के रूप में अपना स्थान ग्रहण करने के लिए आमंत्रित करता हूं. नई दिल्ली G20 लीडर्स समिट डिक्लेरेशन पर सहमति बनी है. संपूर्ण विश्व में आशा और शांति का संचार हो। 140 करोड़ भारतीयों की इसी मंगल कामना के साथ आप सभी का बहुत बहुत धन्यवाद।
To begin our seminar, I would like to request His Excellency Mr. C.D. George, the Ambassador of India to Japan, to deliver our welcome remark.
Good afternoon, everybody. Honorable Chairman of Indian Space Research Organization, Dr. S. Somnathji, Mr. Shantanu Pattavadekar, Scientific Secretary of ISRO, Mr. Jun Kazeki, Director General, National Space Policy Secretariat, Cabinet Office of the Government of Japan, Mr. Hiroshi Yamakawa, President, Japan Aerospace Exploration Agency, JAXA, Dr. Soichi Noguchi and Dr. Naoko Yamazaki, former astronauts of JAXA, members of academia, media, Indian community, students, researchers, dear friends. I am very happy to welcome each one of you to this event that we organize here at the Indian Embassy. This was an event that we wanted to organize for a long time. You have seen the video of the launch of Chandrayaan. I recall watching it live here in this embassy, in this auditorium. The same kind of emotional welcome that we gave for that video today was given all across India to that launch. 1.4 billion people celebrated the launch of Chandrayaan mission when it landed on the moon. I am very happy to see the kind of welcome that received in Japan too. I recall reading the letter from JAXA chairman to our ISRO chairman, congratulating him on that occasion. I also remember reading the congratulatory message from Prime Minister, His Excellency Mr. Kishida, addressed to our Prime Minister, Mr. Narendra Modi, on the Chandrayaan mission, congratulating India for this achievement. In fact, during the last few months, when we went to each of the prefectures in Japan, I had the great honor of showing this video to many business seminars and universities. I am very happy to mention that I saw the same kind of emotional welcome that we saw today by everyone clapping and welcoming that launch. So let me congratulate ISRO and our scientists for the great successful launch of the Chandrayaan mission and a very successful space program. I am very happy today that Honorable Chairman of ISRO, Dr. S. Somnath, has joined us online. I am very happy to welcome him to this audience today. I look forward to his visit to Japan physically in coming months so that we can celebrate together this occasion again with JAXA and with the government of Japan. I am so happy to welcome the Scientific Secretary from ISRO. I'm also happy to welcome our guests who are present here together today with us, Mr. Jun Kazeki, the Director General, Chairman, President of JAXA, Mr. Hiroshi Yamazaki, and also our dear astronauts who had the great experience of being in the space. I had the opportunity to talk to them a little while ago. I'm very happy to hear their experience of being in the in the space. In fact, when it comes to India-Japan relationship, we used to say that sky is the limit. Sky is the limit. But I'm very happy to say that sky is not the limit. Now, not even space is the limit. We have moved on much more than that. A relationship which started several thousand years ago, but in recent times, a relationship which was more government-to-government relationship has expanded, evolved into become a business-to-business relationship. It has become a people-to-people connect relationship, and it has today evolved into a special strategic and global partnership. And I'm very happy to say that this indeed is special. It is, very few countries you see that special strategic relationship between India and Japan. It is special, which was agreed to by Prime Minister Mr. Modi and Prime Minister late Mr. Abe in 2014. Now it is going to be the 10th year when we have this special strategic and global partnership. I am very happy to say that we are moving ahead, including more and more areas, critical technology, emerging technology, and of course, space into our engagement. There is a great engagement between JAXA and ISRO. I'm very happy that we are able to do this event together today, and we look forward to working more closely with the scientific community in Japan and also with JAXA in further building our relationship. So in fact, science and technology has become one of the major areas of collaboration between India and Japan. I'm very happy to note that next year we would be celebrating as India-Japan Year of Science and Technology and Innovation. It would help us further build on our collaboration in critical technology areas, in innovation, in startup, and of course, new areas where our students, researchers, and also scholars and scientists can work together to build a new India-Japan partnership, which helps not just India and Japan, but also each and every country in the region in Indo-Pacific. We have seen how we are working together for the stability, security, peace, and prosperity of Indo-Pacific. In the FOIP. FOIP is a term which Japan uses. India uses IPOI. It is working together for the prosperity of this region. We are also working together in Quad at the plurilateral level. Once again, I welcome each one of you who have joined us today. I look forward to a great evening. We look forward to hearing our leaders from ISRO and JAXA and others speaking today. Once again, thank you and welcome.
Thank you for your remarks, Excellency. Next, I would like to welcome Dr. S. Somanath, Chairman of Indian Space Research Organization, ISRO, to make a special remark. Could I have your attention to our screen?
His Excellency Ambassador C.V. George, the Director General of the National Space Policy Secretariat, the Cabinet Office, Mr. Jun Kaseki, President of JAXA, Mr. Hiroshi Yamakawa, the astronauts, Dr. Soichi Naguchi and Mr. Naoko Yamazaki, all the officials from Embassy of India, Japan's Cabinet Office and JAXA, my dear students, greetings to you all from Bangalore, India. It would have been a great opportunity for me to come and be at the Embassy of India to celebrate the success of Chandrayaan-3 mission. But unfortunately, I am not in a position to travel right now. But still, I am very happy that I am able to connect to you and speak to you through this media. I'm really happy to see that the Director General of National Space Policy and JAXA President to be among the dignitaries for today's events, and the friendship between these two countries has a long history and very strong, based on very strong cultural and civilizational elements. And we have been working together in space sector in the past. As possibly you know that many of the Japanese scientists were in India long back when we started the rocket program in Tumba Equatorial Rocket Launching Station in the southern end of India. And this location is where we started launching our small rockets. And this happened to be the 60th year of the launch of the sounding rockets. And yesterday happened to be the day we launched the first rocket. So we are celebrating the 60th year this week. We'll all remember those people who came and participated in the sounding rocket, low atmosphere, high altitude experiments that were conducted from that location in India. We had a very engaging space as well as successful space relationship in different areas, especially in the area of Earth observation, satellite navigation, planetary exploration, and we also support a lot of regional activity in the cooperative manner, especially the APR staff, the Asia Pacific Regional Space Agency Forum. We also work in together in the Quad working group, as already told by the Ambassador, His Excellency. And the highlight in our relationship is the successful completion of the feasibility study for realizing the joint lunar polar exploration mission, the LUPEX. And currently that detailing of this whole project is currently underway in both the places. And in ISRO, we are very happy to see that the engineering of this has reached some level of maturity. I'm sure this work will really further strengthen our engagement between Japan and India in a big manner. And I'm very happy that the encouragement that is shown by the participation of Japanese side from such high officials in this today's meeting organized by the embassy, so that our further journey in this area in space cooperation will become stronger and more engaging, which is produce very, very important, fruitful results. The JAXA president, we had a very strong engagement and relationship personally. We have been meeting quite often. Recent meeting has been at IAC, International Astronautical Congress at 2023 at Baku, Azerbaijan. And we had also meeting with the Dr. Sako Tsuneta, the vice chair of the Japanese Cabinet Committee on National Space Policy, who personally wished for the Chandrayaan-3 success a few days ahead of the soft landing on Chandrayaan-3 spacecraft on the southern part of the moon. Today, you showcase two important events, both the Chandrayaan-3 success, soft landing, as well as the G20 event. I think these two are very important events in the recent history. As all of you know, Chandrayaan-3 soft landing has been achieved after the very tough journey that we had in the Chandrayaan series of missions, starting with the Chandrayaan-1, where we had an orbital mission, and it had a lot of remote sensing instruments, found very substantial scientific findings, including identification of the presence of water molecules, hydroxyl molecules on the surface of moon. And Chandrayaan-2 was designed as a landing mission, but unfortunately, we were not able to accomplish the soft landing, which prevented us from the in-situ measurements. Today, after many, many years of hard work of understanding what went wrong with that mission, we were able to come out successfully and engineer that mission to a very, very really soft landing, I must tell you. And after that, we had the rover coming out, and also the 5 of the instruments on board working very beautifully, collecting a lot of samples of scientific data. 3 of them in the lander and 2 of them in the rover. And the rover also traveled on the moon surface for almost 100 meters. And we were able to do mineralogical experiments, measurements using the rover. I think all this really will add to the scientific knowledge about the moon, not only in India, but also to the entire scientific community, as has been already described by our Honorable Prime Minister, that this mission is just not for India, it is for the entire world. I think this is something that resonates in everybody's mind. And I must also tell you the G20 event is also an equally important event of coming together of all the G20 nations and having a great engagement with each one of you and working together is also great, is very important. And possibly you know that we have already announced a spacecraft called G20 satellite. And we are actually announcing it soon for soliciting payloads from all the G20 nations to be part of this spacecraft. And this spacecraft will be focused on the climate change, weather, environment, etc. And we hope that there could be contributions from in the form of payloads that we can be hosted on this spacecraft, which will be a remote sensing satellite with many addressing the measurement of essential climate variables and specific observations. Today's event is actually a showcasing of the success of Chandrayaan-3, and there will be presentations on this Chandrayaan-3 and how we accomplished it. And we also hope that the JAXA SLIM mission is going to be a great success, and we will look forward for further missions to Moon, as already been announced by Honorable Prime Minister of India, Shri Narendra Modi ji, that we will not be limiting our missions to Moon just with the Chandrayaan-3, but with future exploration of Moon and other planetary objects, leading to much higher levels of engagement, not only in India but with the other nations around the world. And I'm very sure that experience shared by the NASA astronauts will be a very important element of this discussion. So we still have a very long way to go to reach a level of placing an Indian astronaut in space and bring them back safely. We have a program called Gaganyaan, and definitely engagement with Japan in this direction also will be very good in the future. And I'm very happy that today there are many school students, children participating in this program. And congratulations to you for being part of this session. Space being an inspiring domain, it has been so in the past in India, and Chandrayaan-3 has given such an energy and enthusiasm to many of those people in India. Lakhs of them, students who are students of science and others, wanted to get into higher levels of learning, get into science, technology, which is going to be an important aspect of the inspirational story, other than the scientific outcome that has come out of Chandrayaan-3. And also, I would like to congratulate for the efforts that Embassy of India is organizing the quiz program to rekindle the interest in space and rocketry today. So thank you, Embassy of India, especially the Honorable His Excellency Ambassador, for putting a lot of efforts in organizing this event and bringing us all on board to take this event to all the stakeholders, including students and also top leadership from both the sides. So let me express my happiness to be part of this and look forward to our other leaderships to present and talk in this event. Thank you so much. All the very best.
Thank you very much, Dr. Somanath. Ladies and gentlemen, and especially students, now it is a quiz time. My colleague will be taking over the quiz session. Good luck.
Hello, everybody. We will be conducting a quiz now. I will read out the questions and the options. Those who want to answer, please raise your hand and we will give you the mic. Please give me your name and then the answer. So, let's begin with the first question. What is the name of the first Indian space mission dedicated to observe the sun? The options are Chandrayaan-2, A, B, Gaganyaan, C, Mars mission, D, Aditya L1. That's right. The correct answer is Aditya L1.
As much as possible.
Okay. So the next question is TVD-1, launched in October 2023, is the first test vehicle demonstration of which mission of India? And the options are A, Chandrayaan-3, B, Gaganyaan, C, Mars mission, D, Aditya L1. Yes. We can, you're close, but I'm sorry. Yes. Yes. Sorry. So that's right. So let's move on to the next question. Yuva Vigyanik Karyakram is a young scientist program organized by which institution? The options are Indian Space Research Organization, that is ISRO. Option B, Department of Science and Technology, India. Option C, Ministry of External Affairs of India. And option D, Department of Atomic Energy of India.
Aditya Mishra here. The answer is B, Department of Space, Science and Technology.
Sorry.
I'm Krishan Lumalai. The answer is A.
That is?
ISRO.
That's right. Now, question 4. Who is known as the father of the Indian space program? I'm sorry. Options A, Aryabhatta. Option B, Dr. APJ Abdul Kalam. Option C, Dr. Vikram Sarabhai. Option D, Dr. K. Saban. I know. Lots of hands. Very happy.
I'm Tarun and Dr. Vikram Sarabhai.
Yes.
Okay.
Now, let's move on to question 5. India launched its first satellite, Aryabhatta, on board a Soviet Union launch vehicle in 1975, which was India's first satellite that it launched on its own rocket in 1980. Options are A, Bhaskara, B, INSAT, C, Aryabhatta, D, Rohini.
My name is Shlok and I think the answer is D.
D? That is Rohini?
Yes.
Now, let me tell you something about Rohini. India's first satellite launched using its own rocket was named Rohini. The launch took place on July 18, 1980, using the satellite launch vehicle SLV-3. Thank you.
Next, May I request Mr. Kazeki Jun, Director General of National Space Policy Secretariat in the Cabinet Office, to deliver a remark.
Thanks for having me today. It's very challenging after the animated quiz session, but I'm trying as a representative of government of Japan. His Excellency Mr. Gigi Georgi, Ambassador of India to Japan, Dr. Somanas, Chairman of ISRO, and Dr. Emakawa, President of the JAXA, and ladies and gentlemen and students, good afternoon. Thank you for inviting me today to the space event, which is a timely opportunity to the space community. First of all, I would like to congratulate the Indian moon explorer Chandrayaan-3 on its successful landing near the South Pole of the moon on August 23rd this year. This is the world's fourth successful landing on the moon and the world's first historic landing near the South Pole of the moon. And I would like to express my deepest respect to ISRO for leading the mission to a successful conclusion. I would also like to take this opportunity to express my sincere gratitude to His Excellency Ambassador George for your meeting with Space Minister Takaichi last December. I also thank ISRO Chairman Dr. Somanas for your meeting with Dr. Tsuneta, Deputy Chairman of the Space Policy Committee of Japan, who visited India in August this year. I recognize a fruitful exchange of views on space cooperation between two countries. In fact, Japan and India have been cooperating in various ways. I have three aspects here. The first one is a space policy dialogue between the government of Japan and the government of India. Following an agreement at the Japan-India Summit during Prime Minister Modi's visit to Japan in October 2018, the bilateral space policy dialogues were taking place in 2019 and 2021. During these dialogues, both Japan and India exchanged information on our space policies and exchange views on security, cooperation between space agencies, positioning satellites, space situational awareness, and international rules and norms on outer space. The second one is a Quad, a cooperation among India, Australia, the United States, and Japan on space. Following the agreement at the second Quad Summit held in September 2021 to establish a working group in the space, a satellite data portal was created in May 2022 to provide links to satellite data from Quad countries and started to make it openly available on the internet. In March 2023, the Quad countries organized a workshop to support capacity building of Indo-Pacific countries in the use of satellite data for extreme precipitation events such as floods and heavy rainfall. At the summit meeting in May of this year, the Quad leaders agreed to share knowledge and experience on space situational awareness for the Commercial Space Business Forum and continue to discuss on a peaceful, safe, and sustainable use of outer space. We look forward to continuing to work together with India and the other Quad partners to promote practical cooperation, including capacity building assistance to countries in Indo-Pacific region. The third one is our collaboration in an international fora. In this year, Japan holds the G7 presidency and India holds the G20 presidency. At this year's G7 Hiroshima summit, we reiterated our commitment to promoting the safe and sustainable use of outer space This stated the importance of addressing the issues of space debris and welcomed the nation's effort to develop further solutions for space debris mitigation and remediation, as well as further research and development of orbit debris mitigation and remediation technologies. We have also exchanged views with India in this area at the Asia Pacific Regional Space Agency Forum, APR-SAF, and United Nations called COPIUS. In particular, in the COPIUS working group on long-term sustainability of outer space is currently chaired by Dr. Umama Heswaran of ISRO. I would like to pay a tribute to India's contribution towards international cooperation in this area. In these three areas, I look forward to continued exchange of views and cooperation on space policy between the governments of our two countries in the area of promoting the utilization of space systems to solve social challenges and the long-term sustainability of space activities. Let me now turn to the cooperation between the space agency of our countries. JAXA and ISRO are cooperating on a lunar exploration mission called LUPEX. This mission will be launched in 2025 by a Japanese H3 rocket with a lunar lander to be developed by India and a lunar rover to be developed by Japan. Okay. Thank you. The mission will conduct observations to clarify the amount and the state of water in the polar regions of the moon. We hope that the cooperation between JAXA and ISRO will steadily progress towards the success of this mission. I also sincerely welcome India's signing of the Artemis Accord in June of this year, which aims to promote a common understanding among countries on international rules for future scientific exploration. In addition to the above, cooperation between JAXA and ISRO has been taking place in various fields, such as data validation of Earth observations, positioning satellites, and planetary exploration, and we look forward to further development of cooperation in the future. Now, as a potential area for our future space cooperation, I would like to point out business cooperation. In Japan, through the S-Booster Business Idea Contest and other programs, we are working to discover startups in the space field in the Asia-Oceania region, including India. I understand that India announced its Indian Space Policy 2023 in May this year, which established a stable and predictable regulatory framework for companies through the Indian Space Promotion and Authorization Center in space, and promotes space-related education and technological innovation, including support for startup companies. I look forward to the development of a mutually beneficial cooperation between our two countries in these areas as well, leveraging each other's strengths. Finally, I would like to conclude my remarks by thanking all the participants, including students, today, and such a success meeting already. And thank you very much for inviting me again, and Danny Award.
Thank you very much, Mr. Kazaki. Next, I would like to request Mr. Yamakawa Hiroshi, the president of JAXA, to deliver a remark.
Well, His Excellency, Ambassador George, Dr. Samana, Chairman of ISRO, distinguished guests, students. My name is Hiroshi Yamaka, President of JAXA, Japan Aerospace Exploration Agency. It's my great honor to be part of this wonderful event focusing on space cooperation between India and Japan. And I would like to extend my gratitude to Ambassador George and the Embassy of India for hosting this, graciously hosting this wonderful event. And following the great and historical success achievement of ISRO's Chandrayaan-3 lunar landing in the polar region, I would like to make some presentation regarding the history and the ongoing projects of the Japanese space community. And next page, please. So the cooperation, the lunar exploration of JAXA started about 30 years ago in 1990, when we launched a spacecraft called HITEN. And it is actually a kind of engineering test satellite or spacecraft to demonstrate lunar swing-by technology. I mean, a kind of interplanetary navigation, and also lunar orbit insertion technology. And after 3 years, we completed the operation of this satellite in 1993. On the right, you see a trajectory of this satellite. So at the center, you see the Earth, and you see several the trajectory of the Moon orbiting the Earth, and the blue line shows the trajectory of this HITEN spacecraft. You see, it's like a flower. The flower is realized by approaching several times very near the Moon to change the orbit. So that was the philosophy of this mission. So this was a starting point for Japan in terms of lunar exploration. Next page, please. And then comes Kaguya, which was launched in 2007, and we have completed this operation, the operation in 2009. This is a kind of gigantic spacecraft to focus on the observation of the Moon. It's really a full-fledged scientific observation of the Moon after Apollo program. And this spacecraft was put into the lunar orbit at the altitude of about 100 kilometers with so many instruments to observe the Moon. Next page, please. And this is one of the examples of the outcome of this Kaguya mission. And there was one of the aims of this mission was to observe the Moon precisely, and especially the elevation of the surface of the Moon, so that finally we get the topographic map of the Moon. And based on this very precise map of the Moon, already mentioned by Dr. Samana, right now we are operating Japanese lunar lander, SLIM, and we are utilizing this kind of map to realize safe landing on the surface of the Moon currently. Next page, please. And then comes SLIM, as I said, or already mentioned, this September, utilizing the H2A rocket, number 47, we launched this SLIM mission. S means smart, so this is a smart lunar lander. And right now, we are operating this SLIM spacecraft very safely and sustainably, and I hope that this SLIM lunar lander will realize lunar landing hopefully next. So right now, we are operating this spacecraft. You see so many movie over there, and based on the data taken by cameras and many other sensors, this spacecraft or lunar lander will achieve lunar landing like this. It's very it's a great technical challenge. And you see a very small robot. It's a hopping robot. This robot will be released on the surface of the moon. And the other one, this small robot, is developed together with Sony and the toy maker Tomy. So I think it's going to be a very exciting mission for everyone in the world. And the SMART means that this lunar lander is aiming to realize a very high precision landing technology with about 100 meters precision in terms of the landing site. Okay, next page, please. And then comes the most important mission, LUPEX. So LUPEX means the Lunar Polar Exploration Mission. This is really the symbol of India-Japan Space Cooperation. So as already mentioned, India is developing the lander, and we, JAXA, is right now developing the rover. And you see the rover on the surface of the moon, the lander on the surface of the moon, and on top of that, you see the rover. We are developing this rover right now. So there's a lot of mechanical sequences, and after that, it will rove or dive onto the surface of the moon, and will make several and many observations of the moon. Okay, next page, please. And then comes the Lunar Gateway. This is led by the United States, and currently Canadian, European, and Japanese agencies are working together to realize this endeavor. And the gateway itself is a kind of lunar station, space station. So right now there's an International Space Station, ISS, orbiting around the Earth, but this gateway station will orbit around the moon. And JAXA will provide several instruments to this gateway station. For example, ECLIS, which means Environmental Control and Life Support Systems. We call it ECLIS. And also thermal control systems for this space station. And we're also going to provide cargo transportation function to this gateway, because this gateway needs some cargo resupply, for example, water, food, and mission instruments, and so on. So on the left, you see the currently developed launch vehicle. We call it HTV XG, and this space vehicle will provide cargo to the lunar station gateway. The next page, please. And actually, Prime Minister Kishida announced about 2 years ago that Japan will send Japanese astronauts onto the surface of the moon within this decade. And we have already selected 2 new JAXA astronaut candidates out of 4,000 applicants. So out of 4,000, we selected 2. So it was a very hard process of selection. You see one female on the left and one male on the screen. That time he was in the United States. That's why he couldn't join this press conference physically. But anyway, we have selected 2 new candidates especially for the Artemis program. Next page, please. And then comes the crewed pressurized rover, which right now JAXA is developing for the Artemis program. Because the Artemis program's characteristics is that it's a sustainable exploration of the surface, on the surface of the moon and in the vicinity of the moon. That means we need a very comfortable rover for astronauts on the surface of the moon. If the astronauts can ride on a rover, if they are exposed to space, they can maintain the activity on the surface of the moon for just several hours. But if a rover like this, which is covered and pressurized, then astronauts they don't have to wear spacesuits, so that they can stay inside for at least 1 month. And this rover will move, for example, 20 kilometers per day. And finally, the lifetime of this rover is about 10 years. And finally, we would like to achieve 10,000 kilometers on the surface of the moon for its activity. So it's really a great challenge. But I think that this is one of the greatest contribution from Japan to this Artemis program. And as you can see, we are collaborating with Toyota. Thank you. Next page, please. And already mentioned by Dr. Samana and Mr. Kazeki, the Artemis Accords is a kind of principle, laying the principle for space exploration, for example, on the surface of the moon and other celestial bodies. And Japan was one of the first signatories of this Artemis Accords, which took place in 2020. And since then, there are so many countries joining this Artemis Accords. And right now, there are 32 countries who have already signed this Artemis Accords, including India. And so India and Japan are partners also within this Artemis Accords framework. And the aim, as I said, it's the aim of Artemis Accords is laying a kind of principle, for example, how in terms of sustainable use of outer space and transparency in terms of, for example, lunar surface activities and so on. So this is a very important principle for every country who is trying to engage in space exploration. Next page, please. So I have made some overview about Japanese space lunar exploration program so far, and especially focusing on India-Japan Space Cooperation, and especially in terms of the lunar exploration. But as already mentioned by Dr. Samana of ISRO, we have been collaborating in so many areas, including, for example, Earth observation, tackling global warming issues, and many other areas together. So we would like to further strengthen our collaboration with India. Thank you very much.
Mr. Yamakawa, thank you very much for the great insights. Next, I would like to request Mr. Shantanu Patidkar, Scientific Secretary at Indian Space Research Organization ISRO, to give us a presentation on Chandrayaan-3.
You're able to see the presentation? Okay. His Excellency Ambassador of India to Japan, Director General, National Space Policy Secretariat, President JAXA, former JAXA astronauts, Chairman ISRO. Greetings from ISRO. Good evening, Japan. I'll just make a brief presentation on Chandrayaan-3, the journey to the moon. Next slide. As far as the Indian lunar exploration program is concerned, we have started the journey in 2008 with the Chandrayaan-1, which had a spacecraft which was orbited around the moon, around the moon. And it also had the impactor, which was deliberately released from the orbiter, and it crash landed on the moon. Then we had the second mission of Chandrayaan-2 in 2019, which was a full-fledged orbiter, lander, and rover mission. Of course, the soft landing on the moon could not be established in Chandrayaan-2. I will talk about that in brief. And then we had gone to Chandrayaan-3 in 2023, with a prime focus of soft landing of the lander and then rover rowing on the lunar surface for doing the in situ scientific experiments. Next. If you see about the Chandrayaan-1, which was our first attempt to reach the moon, the total mass of the satellite was 1380 kgs, and it has a design life of 2 years. We carried 11 payloads on the Chandrayaan-1. With India has the 5 payloads. We built 2 payloads with Europe, India jointly, and 2 payloads from Europe and 2 from USA. This particular Chandrayaan-1 mission was in the orbit for almost nearly a year. And the most important discovery which was made by Chandrayaan-1 was it has discovered the presence of hydroxyl and water molecules on the lunar surface by using the payload called mineralogy mapper. And it is almost, we had the 180 scientific publications which came out of the scientific data which was provided by Chandrayaan-1. And apart from the discovery of hydroxyl molecules, it has also done many other findings, like you have seen the reflected hydrogen from the lunar surface as detected by the SARA payload. Also the detection of argon-40 in the lunar exosphere. Next. Next, we had then went to Chandrayaan-2 with a aspiration for the soft landing on the lunar surface, and the mass of the spacecraft around 3,800 kg and design life of around 1 year. It has successfully lifted off on board LVM-3, our heaviest launcher of India, and it has a full configuration of orbiter, lander, and the rover. As far as the soft landing is concerned, we could not, of course, was fully successful in doing the soft landing. As far as the landing initiation phase was concerned, the performance, of course, was fully normal. And also the rough braking phase, the performance was observed normal. But when the camera coasting phase started, we of course observed some larger dispersions were observed. And particularly during the fine braking phase, there was error caused the system to gain velocity and also lose the altitude. In that process, the lander has, of course, crash landed on the moon. Next. However, as far as the orbiter is concerned, it is still orbiting the moon, and it is providing the very valuable scientific data for the global community. And it has a very unique dual frequency synthetic aperture radar, which has now revealed even the craters which are hidden below the surface. You can see in the picture, in the color, you can, because it's a polarimetric data, full polarimetric data, you can see the 1 and 2. These are the craters which are hidden below the surface. And also you can observe the disturbed region hidden by the lunar regolith that on 3 and 4 where it is written. Also, another important thing is about the Chandrayaan-2 orbiter. It has the highest resolution OHRC camera, which is providing almost the images of 25 centimeter resolutions. So these are the sharpest images ever from the lunar orbiter platform. Apart from that, it has also helped to detect the water ice, particularly in the lunar regions, which are not receiving any sunlight, or which does not receive any sunlight. So this orbiter is healthy with all the payloads functioning and still providing a lot of scientific data to the global community. Next. Then, of course, we moved to Chandrayaan-3, and there are plenty of configuration drivers which have, we have taken from the Chandrayaan-2 heritage, as well as the Chandrayaan-2 on the orbit, whatever the lessons we learned from the Chandrayaan-2. We have done a lot of corrective actions and also built the robustness in the lander. Large number of ground tests and simulations were carried out, of course, for the on-orbit testing and evaluation, which has finally resulted in the safe and soft landing on the lunar surface. So the primary objectives of Chandrayaan-3 were, of course, to demonstrate the safe and soft landing, and also to demonstrate the rover rowing on the moon, and then, of course, conduct the in situ scientific experiments. Next. So as I told you, there are many corrective actions we have taken in Chandrayaan-3 with whatever the lessons we learned from Chandrayaan-2 mission. You can see the significant improvements were done in the guidance and control system. We had the improved sensors for the navigation. The lander legs, particularly, more made more stronger and ruggedized, and also there was a increased solar power generation. Apart from that, of course, number of special tests and simulations were also conducted, particularly with respect to the integrated cold test, integrated hot test, and also the lander leg drop tests were done a couple of times. And in fact, we have also built one test site and created some artificial craters for testing for simulating the as far as the Chandrayaan-3 lander landing is concerned. So overall objective was not only to incorporate the lessons learned, but also to validate the performance of sensors and the navigations under different test configurations and the flight profile. The next. So these are the mission elements of Chandrayaan-3. It was also on board LVM-3 was launched. Of course, the M4 mission. As I told you, this is our heaviest launcher, which can carry almost 4 tons of payload. And this was the 6th consecutive successful mission of the our LVM-3. It has 3 modules. One is, of course, the propulsion module, which initially carried the integrated lander module and rover together to the orbit. And then the lander module was there, which has a mass of 1750 kg, and it has a mission life of 1 lunar day. And then the rover, which was, of course, in the lander module, it was made to roll on the lunar surface. And so all this thing is made as a composite. It was launched as a composite module, and it has scientific instruments, as Chairman was mentioning. Lander has the 3 scientific payloads. Rover had carried 2 payloads, and the propulsion module, of course, had 1 payload. So this particular mission, when Chandrayaan-3 was launched on the 14th of July 2023, it successfully took off on board LVM-3 on the 14th of July 2023. And we have conducted the 5 earthbound maneuvers, subsequently followed by 5 lunar-bound maneuvers. And then the lunar orbit insertion was successfully completed on 5th of August 2023, and followed by the lander separation on 17th August 2023. And subsequently, on 23rd August 2023, we have demonstrated the successful landing on the lunar surface. Next. So this just basically briefly shows our powered descent plan, how it was done. And as we told that, we have planned for the a lot of contingency measures also in case if we don't get the altimeter data, or sometimes we don't get any velocity update. So all the contingency measures which can come, or which can probably evolve during the descent phase, were taken into consideration. And we also had the very high resolution images available from our OHRC, which was on board the Chandrayaan-2, so which also helped us to identify the accurate and the precise location to soft land on the moon. And in fact, we had a landing strip of something like 4 kilometer by 2.4 kilometer. And as far as the landing is concerned, almost exactly, it was almost in the center of the landing strip. We were successful to land or soft land our lander. And in fact, as far as the the landing velocity also is concerned, the touchdown velocity also, we were targeting something like 1 meter per second. And finally, what we achieved is something like 0.8 meter per second, we could touch down. So it was almost a successful, precise soft landing could be demonstrated on the lunar surface. Next. So as we were mentioning, basically it has the 5 payloads, 3 payloads on the lander, the Ramba payload, the chest, and the ILSA. And then on the rover, we had 2 payloads, Apex and LIPS, and of course 1 payload shape on the propulsion module. So still a lot of scientific data is being analyzed as far as what we got from the lander as well as from the rover. But I would just like to show a few of the preliminary results what we got from the these data sets. Next. So one of the instrument, the chest, which was on the lander, First time it has probed the few centimeters of the lunar regolith, and we have done the strong vertical observations of the temperature gradient, and it had basically 10 sensors, sensor 1 to sensor 10 throughout the probe, and it has given the quantification of the thermophysical properties in that process. And this kind of measurements are very important inputs if you want to have the future establishments on the moon. And you can see in the graph the temperature profile at different depths of the lunar surface. And other side, you can see how the different sensors which were there on the probe from the sensor 1 to sensor 10, how it has really shown the variation in the temperature profile on the lunar south pole. And next. The next instrument, of course, was the lunar elemental composition, LIBS, and this is also the first ever in situ measurement made for studying the elemental composition of the lunar surface near the South Pole, and it has very interestingly confirmed the presence of sulfur in the region unambiguously, something that was not feasible, by any instruments on board the orbiter, because this particular kind of presence of sulfur requires an in situ observations that you need to be in contact with the surface. And it also had done the preliminary analysis have also shown the presence of aluminium, sulfur, calcium, iron, chromium, titanium on the lunar surface. So this, of course, these are early results. The data is still being analyzed further. The next. We also had the near surface plasma content, measured by the instrument called RAMBA. This is also the first ever measurement of plasma environment, and it also indicates the plasma near the lunar surface is relatively sparse, and a few tens to hundreds of electrons per cubic centimeter. Detailed analysis still in progress. These are only the initial preliminary result. The next instrument, of course, it was on the rover, which has basically seen and observed the movement of the rover around the landing slide, and it has recorded the movement of rover and all other payloads, and interestingly it has also observed some of the seismic events which were captured on the August 26, 2023, and what is the exact source of these seismic activities are still under investigation, but we have seen these kind of activities are observed by the instrument. Next. Another important activity which was done, which was not, of course, planned earlier, it has even exceeded the mission objectives, was the HOPE experiment. After the successful soft landing and doing the experiments of the rover and rover roving on the lunar surface, we have one more attempt was made basically to basically retract the ramp, and again elevate the lander by something like 0.4 meter, and hop it and again land it safely at a distance of 0.3 to 0.4 meter near the landing site. So this was a very successful experiment conducted. It was a sort of re-hopping experiment. And one more interesting study was done using the Chandrayaan-3 when it was landing during the descent phase on August 23. So when the landing was being done, it has really generated one very spectacular, you can see the ejecta halo of the lunar material, which basically it was estimated that around 2 ton of EP regolith of the lunar surface, it got displaced because of the landing, and it got displaced and spread around the area something like 108 square meter, that entire soil which got displaced in this area. Next. This is of course our next joint mission, which we are proposing as a ISRO-JAXA endeavor to explore the lunar south pole, LUPEX. And the idea of this particular mission is to further scout for the lunar water and search for the water ice at different locations on the lunar surface, particularly in the PSR region, that is called the permanently shadowed region on the moon. We can scout for the lunar water. It will also do the in situ sample analysis, where the samples will be scooped out of the lunar surface, and then the experiments, or you can say in situ analysis, will be done on the rover and as well as on the lander. So the joint feasibility study has been completed, and we had a lot of interactions between both the teams from ISRO and the JAXA. This entire mission is, of course, under the approval or governmental approval cycle at ISRO and Government of India. So this joint mission, of course, will be a joint lunar pole exploration mission between ISRO and JAXA in order to characterize the volatiles and their composition in the lunar polar region. So I think this is going to be a mission which is very ambitious, and of course it will be a extension of Chandrayaan-3, and of course also the SLIM. So both these rovers and landers, what are the experiments they have conducted, I think LUPEX will further take ahead those data sets, and the analysis will be carried out by the Chandrayaan-3 as well as by the SLIM. Next. So thank you very much, and we had, of course, the participation of more than 100 plus Indian and international companies.
Thank you very much for your valuable insights, sir. Thank you very much. Now we're thrilled to invite Dr. Noguchi Soichi, former JAXA astronaut, to share his experiences in the space.
Well, His Excellencies, Ambassador CP George, distinguished guests, my friends, and dear all future young astronauts. Namaste, good afternoon. My name is Soichi Noguchi. First of all, I'd like to congratulate the successful landing of Chandrayaan-3, as we just witnessed. What a remarkable achievement. And like to see all the best wishes for the future missions coming between Japan and India. Today, I'd like to use my time to share my experience. What about my experience? Well, I had chance to fly to space 3 times, 340 days, 3 different spaceships, 4 spacewalk, 3 different robot arms, blah, blah, blah. Yes, I did a lot of things as an astronaut, but the best experience I like to share with you is the beautiful Earth. We can see every day from a space station. Earth is bright, Earth is blue, Earth is living. It changes every day. And the scenery, you see the mountains, beautiful mountains of Himalayas, beautiful Mount Fuji, and you can take picture of River Ganges and the bright city lights of Mumbai. Every day is a new day. You can take thousands of pictures. You can send it to your friends, your families, and you will never get tired. But the beauty of the Earth makes me wonder how we can maintain this beauty as it is. In other words, how we can make it sustainable. Of course, you hear a lot about the recent change in Earth's environment. We used to say global boiling, not more global warming. So Earth is quickly changing. So we have to do something. Like Ambassador CP George earlier mentioned, space used to be space is limited. Now space is no limit. It's actually space is only the beginning. And we can use this beautiful cooperation between Japan and India, starting from a space, expand to other area of science and technology. You can use the communication, you can use the IoT, information technology, AI, you name it. The key is we have to work together to keep this beautiful planet as it is. Also, we have to make sure that our beautiful relationship will continue. I want to share my other experience. I have a very good friend in India. His name is Rakesh Sharma. Rakesh Sharma, he used to be an ace pilot. He was a wartime hero. He became astronaut. He became cosmonaut in late 1970s, long before Japan started thinking about spaceflight. He actually flew to space in 1984. That was before any of the Japanese astronauts was selected. In short, he is the legend. But he's a very nice person, very down to earth, and we became good friends. I have fortunate enough to meet him and have a meeting together a couple of times, various variable locations in the world. And he truly believes in international friendship, mutual trust, and the importance of all the astronauts and cosmonauts work together to emphasize the beautiful Earth, the meaning of keeping the beautiful Earth and the meaning of international cooperation. So my hope, all the young astronauts, you will continue this beautiful friendship between Japan and India. And someday, some of you, or all of you, have a chance to fly on the Gaganyaan, India's first spaceship, and fly to moon, drive Toyota, and then you say, international friendship is the true meaning. And hopefully, we can work together in the space business in the near future. Dhanyawad.
Thank you very much for sharing the incredible experiences with us today, Dr. Noguchi. Next, we're thrilled to invite Dr. Yamazaki Naoko, former JAXA astronaut, to share her experiences in the space.
Good afternoon, His Excellency Ambassador George, distinguished guests, and all dear students. I am Naoko Yamazaki, and I am delighted to be here with you to celebrate, next please. The first of all, the successful Chandrayaan-3, next page please, mission. I was watching the live stream on internet, and I was so excited to witness the very historical moment of the Chandrayaan landing. So congratulations to the ISRO and the entire team. Could you go to the next page? Okay, thank you so much. And could you go to the next? Okay, thank you so much. And only 3 days ago, I attended the APSG Space Generations workshop. So it is a workshop for the multiple generation, including the younger generations like you, to discuss about space across the Asia Pacific region. So it was held in Bangalore, India. And I wish I could have been there in person, but I attended remotely online. And I was so excited to share my experience with lots of people there. And I will discuss lots of future collaboration as well. So next, please. And in the past years, I had an opportunity to attend some Indo-Japan Study Culture Center. Have you heard of that as well? I'm so glad to hear, learn about the joint learning platform like this. And next, please. And also to celebrate International Women's Day together among India and Japan. Next, please. Okay, so as Dr. Yamakawa mentioned, we have new astronaut candidates, Artemis generations. And so far, 14 Japanese have flown to space, 3 private and 11 JAXA. And Soichi Noguchi is a legend. And I'm so delighted to be able to learn from a lot of legends like Soichi and from other international astronauts, cosmonauts, taikonauts, and really looking forward to seeing more collaboration between, younger generations on Gaganyaan generations and Artemis generations. Next, please. Enjoy microgravity. There is no absolute and down. You can make any posture. And you can just use one finger to move around like a fish. And human beings have a good adaptability to get adjusted in new environment, even in a microgravity. And you will enjoy it. Everybody gets strong in space. And that's great. And it is a world record to have 4 women at the same time in space. I'm so delighted. We are proud of it. And record is to be broken. So I hope you will break the record in the future. Right? So from the window of the International Space Station, as Soichi mentioned, I was so impressed with the beauty of the Earth and the beauty of India. And the both home have two versions, but power and the powerful language are very impressive. And next week at night, instead, yes, city lights, human civilization is so strong. So I felt if we can put our strengths together, we can achieve a better goal. So, especially in New Delhi on the top, it's so bright, and you can recognize many cities, right? And next please. And there is a satellite, also civilized. So next please. So after returning back to the Earth, I am serving for Mr. Kazaki as a member of Basic Policy Committee. Also, I'm encouraging space business as a representative director of Space Policy. And I devote myself in education as well. And this is my emphasis as well, is in an prize launched by Prince William in 2020. And just recently, we announced the new winners of the art shot. The art shot is to protect our environment. Each year, we give a winners to 5 winners to protect air, ocean, nature, and to build waste river and fix climate change. And this year's winner is Ms. Nidhi. She is from India, and she is a co-founder of to build a waste-free world to reduce the food loss. So congratulations to her. And also 2 years ago, on the first year of the Arshad Prize, the finalist was from India. She was a young lady, and she was only 14 when selected as a finalist. She was individual, and she invented a new ironing part utilizing the solar power instead of traditional. So congratulations for your contributions. The reason why I am supporting this prize is because the spirit of the art shot comes from the moon. during Apollo era, which made impossible possible in a decade to combine all our resources and wisdom together. So we'd like to cherish this spirit to expand to fix our home planet, the Earth, right? So next, please. And speaking about the moonshot, now the next moonshot is Artemis. And instead of just one country, now we emphasize international collaboration. Next, please. So to conclude, let me share just one personal story. When I was at the 12, I met one lady from India, and I'd never been to abroad at that time. And she was wearing a beautiful sari, and we met in a small ramen restaurant in a suburb of Tokyo. So I was, watching her curiously, and she approached to me, and she was, because I was nervous, but she smiled and said to me, "Well, it's big." And that was a great inspiration to me for my year. So I'd like to echo this to making our friendship and our collaboration deeper and deeper. Thank you so much.
Thank you very much, Dr. Yamazaki. Okay, students, you must be all ready for the next quiz session.
So next, move on to the next part of the quiz. Let's start. The ISRO Propulsion Complex is where the ISRO tests its engines during development and before major launches. In which place is this facility located? Options. Option A, Sriharikota. Option B, Thumba. Option C, Tirunelveli. Option D, Ahmedabad.
My name is Sayuri, and I think the option is A.
Which is?
Sriharikota.
You're very close. Next, anybody?
Hello, my name is Abhigna, and I think the answer is B.
Which is?
I think it's B. I don't know. Answer.
Okay, I'll give you. It's Pragya. You're right. No, sorry. It's Tirunelveli. Tirunelveli. Okay. Next question. What is the name of the Chandrayaan-3 rover? Let me give the options. Please. Option A, Brahmagupta. Option B, Pragyan. Option C, Galileo. Option D, Apollo 11.
My name is Lakshmi, and I think the answer is Pragyan Rose.
Yes, I knew. I'm sorry. So, next question. What is the correct answer about the approximate total distance traveled by the Indian lunar rover in Chandrayaan-3 on the lunar surface? Options. Option A, 1 kilometer. Option B, 500 meters. Option C, 100 meters. Option D, 10 meters.
My name is Harsh. I think the option is C, 10 kilometers. Huh? No. Oh, I mean 100 meters.
I'm sorry, very sorry.
My name is Xiang, and I think the answer is A, 1 kilometer.
I'm sorry.
My name is Danish, and I think the answer is B, 500 meter.
Damn it. Let me give you the answer. Should I give you the answer? Okay, one more try.
My name is Aditya, and I think it's 100 meters.
So the next question is, what is the name of the landing site as coined by the Honorable Prime Minister of India, where the Chandrayaan-3 land rover soft landed? Options are option A, Tiranga, option B, Shiv Shakti Point, option C, Bharat, option D, Vikram.
Hello, my name is Ranavi, and I think it's option B, Shiv Shakti Point.
Absolutely right. So the last question, okay? What is the name of India's first space-based astronomical observatory? Option A, Salute 7. Option B, AstroSat. Option C, Progress 1. Option D, Sigma 11.
I think it's the option D.
Option D is what?
Sigma.
My name is Shivaji, and I think the answer is B.
B.
What's that? I forgot.
So I'll give it to you. It's AstroSat.
Yeah, AstroSat.
Yes. So thank you for the answers and congratulations to all the winners.
Now we would like to present prizes to the quiz winners. May I invite His Excellency the Ambassador and Mr. Yamakawa to come up on the stage? And all quiz winners, please come onto the stage. Now we would like to have a group photo. Now we would like to have a group photo on the stage. Could I invite Dr. Yamazaki? May I please come onto the stage? To conclude our seminar today, I would like to request Mr. Sanjeev Manchanda, the first secretary at the Embassy of India, Tokyo, to give an end-note address.
Wow, what an event we had. So we would just like to give a vote of thanks. It's my pleasure to be here to deliver this vote of thanks. To begin with, I would like to thank our ambassador, His Excellency Mr. C.B. George, who has been the driving force behind this event, and we have worked under his guidance to bring this event to fruition. Thank you very much, sir, for all your guidance. Our special thanks to Dr. S. Somnath, Chairman, Indian Space Research Organization, ISRO, and Mr. Shantanu Bhatwadekar, Scientific Secretary, Indian Space Research Organization. Listening to you and looking at your presentations, I'm sure the audiences would have been very enamored and thrilled in pursuit of their future space endeavors. We are also very grateful to President JAXA, Mr. Hiroshi Yamakawa-san, for coming over here and honoring us with your presence, sir. We are indeed very grateful. We are also thankful to Mr. Jun Kazeki, Director General, National Space Policy Secretariat Cabinet Office, for having collaborated with us and coming all the way to the embassy to participate in our event. A special vote of thanks goes to Dr. Soichi Noguchi and Ms. Naoko Yamazaki, the former astronauts of JAXA. I'm sure the young minds here have been very thrilled by your achievements in this space, and we do look forward to collaborating all of you in future for more such events. Thank you very much for being present here today. Arigatou gozaimasu.
Now we would like to conclude the Indian Space Sector Surgeon Ahead Celebrating Chandrayaan-3 seminar. Thank you very much for your participation today. We have a networking session with some refreshments and tea at the lobby. We hope you all enjoy it. Thank you very much.